So I had a couple of students emailing me asking how do I use Excel to graph my data. So I figured I'd try to make a video and see if this helps you guys making your graphs, and also to do like the standard deviation part of your analysis for the golf ball lab. So the first part is you need some data. I'm going to make up some numbers. We'll give it trials. We'll give times. Right. One of the nice things with Excel is that you can have the numbers do sequential, so that if I put in 1, follow it with 2, and I highlight 1 and 2, and then I can drag down. So Excel has this function where the cursor, if you put it over the bottom right hand corner, you can drag down and increase increments up to as many as you want. So I can make it 6, I can make it 10. Right? So I've got my trials 1 through 10, and I'll pick some times kind of similar to what we had in the lab. So let's say 0.5 seconds, 0.6 seconds, 0.8 seconds, 0.6 seconds, 0.7 seconds, 0.9 seconds, 0.7, 0.5, and 0.8. Right? So we got a whole bunch of time. So next we want to have our average time, so we type in the word average, and the average is going to be equal to, so what we can do is you can make a function. You type in the equal sign, and then you type the word average, right? Then with the open brackets you select all the data you want the average from. So we want all that data, we highlight everything, close brackets, hit our average, and there we have our average. Okay, so that's pretty straightforward, right? So we have our times, we have our averages. So let's first figure out how you can make the position versus time graph, right? So what we want to have is we want to have some times, and we want to have position. Right? So position is, you can think of it as a function based on time, where we use an equation that's equal to, that says that the position or the distance is equal to the initial velocity times the time plus 1/2 the acceleration times the time squared, right? But in this case we don't need the whole thing because the initial velocity is 0. So we can just say the distance is going to be equal to 1/2 the acceleration times the time squared. Okay, so we have our equation right there. Now, so Excel will let you use this equation to fill in your positions for you. So before we can fill in our positions, we need some times. So we know the biggest time is going to be 0.6, so we want the time to start at 0 and go up between 0 and up to 0.6. So like we did for the first time, we want to have an increment. So after 0, let's make it 0.05. Right? So that's 5/100ths of a second more. And if you highlight the two boxes, 0 and 0.05, you've set up like a spacing between 0 and that first number. And then on the bottom right hand side you can drag it down as far as you want it to go, down to let's say 6.5. Okay, so now that you have that, you can figure out the position. So to figure out the position, you need to have the acceleration. You need the acceleration. So in one of the classes I showed how to find the acceleration. There was an equation that said we basically used d equals vit plus 1 fat squared. So you can use d equals vit plus 1 fat squared, and let me pull it up over here, right? So you can see the equation now like it looks like we normally use it. So to calculate our acceleration, we need to rearrange this equation so that we get the acceleration by itself, right? So first thing we would do, I'm just going to use Microsoft Word. And by the way, Word has a great equation editor. Lets you put in your equations so you can have a professional product. So I'm just going to copy and paste it. I'm just going to show you the steps, how we would go from having the equation turning to just for the acceleration part. So I'm just going to recopy it, right? So the first thing I want to do is I want to get everything away from the A. So since it's, one thing we can do is, well, our initial velocity whenever we drop a golf ball is 0. So just get rid of that whole VIT part, right? And already we simplified it, so now it's just d is equal to 1/2 AT squared. To get rid of the half, right, we're going to multiply. Let's see if I can get the multiply symbol right up there. Multiply this times 2. And whatever I do to one side, I'm going to do the same thing to the other side. So we're going to take that side and also times 2. Right? So the 2 will cancel out with the half, and our new equation is going to be, I'll just highlight everything again, copy it, and then enter, Control V. Our new equation, getting rid of the multiplication, canceling out the half. Our new equation is 2d is equal to AT squared, and that times 2 also disappeared. So to get rid of the t squared, I'm just going to divide, right? What I can do for this is I'll show it as a fraction. I'm going to insert, go to design, change that to a fraction. I'm going to divide that side by t squared, and I'm going to divide that side by t squared, right? So the t squared here cancels with the t squared there. Now moving down one more line. So our final answer, this t squared on top cancels with the t squared on the bottom. We can just delete that. I'll get rid of the whole thing, right? This is just going to be a now, right? Because the t squared here divided by the t squared on the bottom cancels out, and we left with our equation that I showed in class. So basically this is a lesson I did in class, but this shows the progress using Word. You can actually see line by line. So when you go to college, you do any kind of math work like this, your professors will be really impressed. It looks like you got a professional product. And I can rearrange this thing so it's not equals to A, but A is equal to, it makes it look more like, we're looking for A, right? So now I'm going to take this equation, and we need some stuff, right? So we're missing our distance, and we're missing we have our time. The time is this average time. Let me fix that. Average time, right? This is the average time. Okay, so let's pick a distance. So let's say, in this case, the distance is 2 meters, right? And so then for our case of this particular set of data, our acceleration is going to be equal to 2 times 2, which is our distance, right? And we're going to divide that by the average time squared, right? Now, based on the stuff set up for the lab. So we find in this case the acceleration is 9.18. So that's practically perfect to what the ideal is going to be. All right. So now that we've got the most important pieces of information to get, we have our average time. We've got the final distance. So we shouldn't really go anywhere past 2 meters since that's how far it fell. So our position should never wind up more than 2 meters, right? If we did, then it means we probably made a mistake. And we have our acceleration, and let's kind of cut down on digits. You don't need that many digits. I mean, with our stopwatch, we could only measure 2 digits, so let's just say 9.2, right? 9.2. Okay, so this is 9.2, and that's always in, meters per second squared. Right, that's the acceleration. I know. Don't forget your units. Seconds for our time, and our distance should be meters, right? So I think that's all nice and clean. Now we can define a function that'll give us the position for each time, right? So the way you do it, the first thing you do is you click on the box that's under the position column, and you type into the where it says FX, you put an equal sign, right? That always tells Excel when you put an equal sign that you're going to define some sort of math machine to find a value. So that function is going to be the d equals VIT plus 1FAT squared. Notice it just keeps coming over and over again. But we don't need the VI because we start again from 0 in this case, or dropping from rest. So we're going to set it going to be equal to 1/2. So I'm just going to put 0.5 because it's a little faster to write in Excel. I'll put, what's it called, parentheses around it to make sure that Excel knows it's just 0.5. We're going to times that by the acceleration, and the acceleration in this case was 9.2, right? And then finally we're going to times that value by the time, which is the value. I click on the box that the time is sitting in, right? So in this case it's F2, but if you're like over here, it would be D2, whatever column you're in, it'll have the letter that's the column that the data is in, and the number is the row, right? That's how all Excel is. It's the columns are letters and the rows are numbers. And if I did this all right, just hit enter, and boom, yay, okay, it's 0, right? Which makes sense because 0 times anything 0, so 0 times 0. So then I could do the same thing again. I could take this function up here and I could type it into the line below it and get the same thing. But the great thing about Excel is, and this is what will save everyone time when you learn it, is you can just repeat the same function all the way down and not have to retype it over and over and over again. When I click, I take my cursor again, move it to the right hand corner like this, and you can see how it changes from being like a fat cross to a skinny cross. I click and I drag, right? And now, right, now I have the position in meters, right, because that's the distance, for at 5/100ths of a second. And if you look in the function, you see that what used to be F2, now it's looking at F3, right? And so I want the rest of it though, so I'm just going to highlight everything, drag it down, and boom, that's all my distances. Something's a little wrong here because it's saying the time hitting is 6, and we picked a distance of 2 meters, so it's a little off, but you get the idea. The idea is that for every time that goes by, pick it up into this equation, and it'll give you all your different positions, right? Okay, so then you should have, finally, after you've done all this, where you've calculated your acceleration, you found your average time, you have your distances, you plugged in the function that's the d equals 1/2 AT squared, you get all your data values, right? Now I'm just going to delete this now because we don't need it anymore. You can just make a graph of it, right? So I highlight both columns, right, so that all my data is covering. It looks like this one's not selected, but really whenever you highlight, it'll always take that first box you clicked and keep it white colored. I don't really know why, but it just is. It's selected though. So I'm going to highlight everything in these two columns. Then I go over to Insert, and then where we got? We want to have a scatter plot, right? It looks like a insert scatter plot. Then we want to have the regular one, and so there you go. That is the deal. Well, something's not quite right. Why does this look like it's a linear equation? Oh, I see what went wrong. I forgot something, right? It's okay though, because you can see how this is right away. When I looked at this graph, I knew something was off because it's a line, right? Turns out when I made this, see how it says times F2? The equation's not times time, it's times time squared. So you might make the same mistake. Be careful. Make sure at the end you have that raised to the second power. Now check this out. Seeing that I made that mistake, I can go back into the function and edit it. And when I edit it over here, watch what happens to the graph. See, right now it's a nice straight line. When I fix the function and I reestablish it, it fixes the whole graph. So the great thing about Excel is once you kind of get a handle on it, you can fix mistakes just by editing, you know, functions when you catch something you screwed up or made a mistake, right? So now this is almost there. It looks like a nice graph, but we need to kind of make this a little better. So what we need to go is under Design and Quick Layouts or Layouts. You'll find something that has layouts. We want to have axis titles. We want to know what's on the x-axis and what's on the y-axis. So here we want a nice something that's simple. This is simple, right? So the bottom is going to be time, and the unit is seconds. The vertical is distance, and the unit is meters. And this is, no, what is this thing? Get rid of that. And this top part is a graph of, what is this? The position versus time, right? Nice and simple. We don't need it anything complicated. Now, if you have the lab, all you got to do then, if you've got it digitally, if you got the Word document, I didn't bring it up right now, but you can just right-click on the graph, go down to Copy, and then over here, right-click, and you can paste. And it gives you a whole bunch of different ways you can do it. So let's just do it the easy way. You can do a picture. It really doesn't matter how you do it. Let's just do a picture, right? And so now your graph is in your work, and congratulations. Okay, so that's for the position versus time graph. The second one we want is the velocity versus time graph, right? Well, it's the same process. The only difference this time is instead of this equation that's the d equals vit plus 1 fat squared thing, we only need we can do it a little simpler, right? We know that so I'm just going to redo it. I'm going to copy the whole time thing, right click, copy, go here, and then I paste the values, right? Type velocity right there. And so now we have to define a new function that'll give us our velocity from each time value, right? So the one that I talked about in class was, just insert, make ourselves a new equation. We know that acceleration is equal to your, there it is, change in velocity. Let's turn that into a fraction. Your change in velocity divided by your time, right? That's the easiest equation, the essential equation for acceleration. So in this case, since we start at 0, right, it's really not, it's gonna, your final value will be the velocity. So you don't even need to have the delta in for this particular case, because if you're starting at 0, the change is, it's just going to give you your velocity. It's just, the total velocity. So what I'm going to do to get velocity, simple way to do it, is to multiply both sides by t, right? We did this in class. Let me see if I can find, there it is, right? Times this side by t times that side by t. I'm going to highlight both. And I mean, I could probably, do this in one line, but I think sometimes it's helpful just to see the progression of the work so you can kind of tell how I got what I got. Right, so we started with acceleration is velocity divided by time. We multiplied both sides by t. T divided by t is 1, right? So this thing basically cancels each other out, and you're left with just velocity. And, instead of writing it times acceleration, I'm going to just write it as acceleration times time, right? So we know our velocity is going to be equal to the acceleration times the time. So going over here, right, they just make a function, right? The function is going to be equal to taking the acceleration, which was 9.2, and I'm going to multiply it times the time. In that case, that's the number that's in box F20, right? Column F and row 20. Right? And we hit enter. Wow, it's 0 again. Yes. So 0 times 0 is anything is 0. And then we take that value and we drag it all the way down, and boom, there's all our velocity. So if this thing falls for 0.65 seconds, it should be moving at 5.98 meters per second, right? And of course, we should have our unit. Meters per second. Great. Okay. Whew. Almost done. Finally here, we highlight both columns. Go up to Insert, then to Scatterplot. And there you go. That's the deal. That's the whole thing. Right, we basically are done. We can fix the layout really quick, make sure our titles are right. I'm just going to steal that, save myself some time. Control C copies. Holding down the Control button, pressing V pastes. Oh, jeez. And then we want to keep text only, so that way we're not changing sizes around. And then the vertical column this time is going to be velocity. Right? And then this is the velocity versus time graph. Oh, gotta have your units. Never forget the units. Meters, second. Great. All right. And there you go. You want to bring it into your lab. Right click on, just click on the graph. Right click. Click on copy. Go over to your Word document. Just paste it, and you're done. And that, in a nutshell, is how do you go from your data all the way to having your position and velocity graphs. I'll probably make another video that explains the standard deviation soon.